So to go into the details of this, the membrane effect, insulin acting on the insulin receptors, increased cell membrane permeability, increased intracellular dose intensity, lowered total dose of drugs, reduced dose-related side effects. Excuse me for the redundancy, but I practice this thing that say, tell them what you told them, and then, no, first, you tell them what you're going to tell them, then you tell them what you told them. So I'm doing that. Keep at it, because otherwise it doesn't get through. Mechanisms of the membrane effects. This is what I think, and there's some interesting stuff in the literature to support all this. Insulin activation of delta 9 desaturase. Let me just say that there's a very complex, wonderful mechanism involving insulin receptor interaction. It's one of these phosphokinase things that it activates itself. It's autophosphorylated, gets endocytosed, and it goes around and it turns on the glucose transport protein, which comes out of a little vesicle and attaches to the cell surface and exteriorizes its internal membrane, which has these glucose transport proteins on it, and that's how glucose gets into the cell. And I didn't go into that in detail because it's really complex. But I don't think that's what's going on with the cancer, with what's going on with the increased cell membrane permeability that we see with these supraphysiologic doses of insulin that allows apparently more drug to get inside the cancer cell. This is what I think is going on. Stearic acid, saturated long-chain fatty acid, is transformed into oleic acid, monounsaturated. The melting point of the triglyceride of stearic acid is 68 degrees centigrade. The melting point of the olein is 5 degrees centigrade. At 37 degrees centigrade with physiologic temperatures, membrane fluidity and permeability will go up. Membrane fluidity is a function of the melting point, and membrane fluidity and permeability are they correspond to each other. And there's a citation I also read recently about how studying certain lymphoblasts, they found that there was a very much higher proportion of oleic acid than stearic acid in the cell membrane. And they thought that had something to do with the insulin stuff. Other possible mechanisms, and these again are also in the literature, and I just put them in for the sake of completeness, is possibility of drug adsorption onto glucose molecules with transmembrane transport then occurring via the insulin-activated glucose transport protein that I just graphically described a second ago. Or, third, adsorption of drug molecules onto insulin with the resulting chimeric drug-insulin complex being internalized into the cell by a process of receptor-mediated endocytosis. As I mentioned, the insulin complex is a receptor, it's autophosphorylated, and whoop, goes inside the cell. And they've taken a diphtheria toxin. There's a bunch of studies where they took one of them was a diphtheria toxin, and they attached it to insulin, and they proved that it got inside the cell, and this was the mechanism.